welcome to the deep dive. I'm so glad you could join us today because looking at the stack of materials we are working through, honestly, at first glance, it looks like a hacker's manifesto.
It really does. It's a lot to take in at first.
Right. We've got complex network configurations, architecture diagrams, routing protocols. But once you actually get past that initial technical wall, it reveals itself as this incredibly fascinating series of blueprints for decentralized file sharing.
It is a remarkable collection of documents. It looks intimidating from the outside, but it is actually deeply practical.
Yeah.
What we're looking at are essentially step-by-step frameworks for anonymous torrenting.
Yeah.
But more specifically, and I think more importantly, it's about how to build a bridge between two completely different digital worlds.
You have the everyday public internet that we all use, right? Often referred to in this context as the Clearnet.
Exactly, the Clearnet. And then you have the hidden, encrypted networks running quietly beneath it all, like I2P and Clearnet.
Okay, let's unpack this, because there is a massive core problem that this architecture is trying to solve for you. The public internet, the Clearnet, has millions upon millions of torrents. Practically any file, dataset, or piece of media you could ever want is floating around out there.
Right.
But when you move over to these hidden networks like I2P, they suffer from a severe lack of content. It's like having a top-of-the-line, ultra-secure underground vault, but when you open the door, there's barely anything inside it.
That's a great way to put it. And that dichotomy really sets the overarching theme for our deep dive today. We aren't just talking about how to download a movie or a software file. We're talking about the mechanics of digital altruism.
Digital altruism, I like that.
Yeah, these concepts teach everyday users how to become a literal, functional bridge between two isolated internets. It's about taking that massive abundance of the public internet and safely piping it into these secure, anonymous spaces for people who genuinely need that layer of protection.
Right. And before we get into the exact mechanics of how you do that, I want to play devil's advocate on the why.
Sure.
If the Clearnet already has everything I want, and hidden networks are ghost towns, why would someone go through the trouble of using I2P or Clearnet for torrenting in the first place?
Well, it comes down to a few very powerful structural benefits that the standard internet simply cannot offer by its very design. When you use the I2P network for torrenting, you are getting full anonymity and privacy at the protocol level.
Meaning no one knows who you are.
Right. There are absolutely no IP address leaks. On the regular internet, when you torrent something, your IP address, your digital home address, essentially is out there for anyone in the swarm to see.
Anyone can just look at the list of peers and see it.
Exactly. In I2P, your IP address is never exposed because the network uses its own internal cryptographically generated addresses. They look like these long strings of random characters ending in .def-b32.I2P.
So it's a completely enclosed ecosystem.
It is.
But there is another major technical benefit mentioned here, something called NAT traversal and hole punching, which sounds incredibly aggressive, but it actually solves a very common headache for anyone who has ever tried to set up a home server or a peer-to-peer network.
It does sound like a martial arts move, doesn't it?
Yeah.
But conceptually, it's brilliant. Think of your home router's firewall as a very strict bouncer at a club.
Okay.
It naturally wants to block incoming peer-to-peer connections to keep your network safe, which usually forces users to set up complicated manual port forwarding. NAT traversal and hole punching essentially allow the network to automatically negotiate with that bouncer.
It figures out a way to sneak the data through the back door without you having to completely reconfigure your router.
Precisely. And to access this, I2P offers two main software engines you can run. There's the original one based on JVA, and a more lightweight one based on C++R, which is called I2PD.
And then there's the Clearnet alternative. The author of one of our sources points out something quite revealing about it.
Oh, about the browsing experience.
Yeah. They tested Clearnet and found it actually didn't work very well for general, everyday website browsing. It was just too clunky.
Right.
But they discovered it acts as a fantastic, secure tunnel specifically for torrenting. If you can't find a file inside the I2P network, you can use Clearnet, bind it directly to a torrent client like BitTorrent, and use it essentially as a free VPN to download from the public internet safely.
What's fascinating here is that these tools represent a deep, foundational desire for privacy that goes far beyond just hiding what movie you're downloading.
We are talking about dissidents sharing information, journalists moving sensitive data sets.
Or just people who believe their internet traffic shouldn't be commodified. Over 90% of torrent users are looking for exactly these features. Full anonymity, no IP leaks, bypassing firewalls.
But there's a catch.
Huge catch. This entire ecosystem relies completely on user participation. A decentralized network doesn't just exist on a server farm somewhere. It's made out of the users themselves. If people don't actively bring content into these secure spaces, the spaces remain empty.
Here's where it gets really interesting, because that brings us to the magic bullet in this whole architecture, that concept of mixed mode, which is also referred to as bridging or network mixing.
This is the absolute core of the digital altruism we were talking about earlier.
But wait, if I'm tying a massive public swarm, the Clearnet, to a small, encrypted, hidden network, doesn't that massive influx of public traffic risk exposing the I2P users? That seems like a glaring security hole.
It's a great question, and honestly, it's exactly why people are hesitant to do it. But the architecture prevents that exposure. The client software acts as an airlock.
An airlock.
Right. It downloads pieces of the file from the public internet, completely scrubbed of their origin, and then re-encrypts and broadcasts those pieces into the I2P network. The public users have no idea the I2P users exist, and the I2P users never interact directly with the public users. You, the person running the bridge, are the only ones standing in both rooms.
That makes a lot of sense. The airlock analogy is perfect, because right now, the biggest obstacle stopping people from bridging these networks is mostly a psychological and educational barrier.
Definitely.
There is a major search index inside I2P called the Postman Tracker, and it suffers because users mistakenly think they have to use a specific, somewhat clunky piece of software called I2P Snark to build brand new torrent files completely from scratch if they want them to work on the hidden network.
Which is a massive hurdle. People assume the darknet has to be a walled garden. They also worry about incredibly slow swarm speeds, so they don't even bother trying.
And thirdly, they think that just by checking a box in their software that says I2P, they are automatically sharing their files with the hidden network.
Which is entirely false. Checking that I2P box only creates a safe tunnel for your specific connection. It protects you. But you aren't actually seeding that file to the Postman Tracker for other people to find.
Actual I2P users cannot access your file unless they have the exact same underlying torrent metadata that you do.
Precisely. You have to actively point the file toward the hidden network. And instead of creating a new file from scratch, there is a brilliant cross-seeding process to solve this, specifically using a client called BiglyBT. It's essentially a clever text hack.
Right. Rather than getting bogged down in the UI clicks, the concept is beautifully simple. You basically open the file's routing code, you delete the public road signs, the trackers pointing to the Clearnet, and you swap them out by pasting in the hidden coordinates for the I2P network, like the Postman Tracker.
Exactly.
Yeah.
You are modifying the routing logic of the file. You might see an error message in your software at first for the Postman Tracker because it's trying to route a public connection to a hidden address.
Right.
But the protocol figures it out because this is now a mixed privacy torrent. Once you save that modified file, you just upload it to the Postman index inside the I2P network.
So when you run it, your software will simultaneously download and upload on both the public internet and the hidden network at the exact same time.
Yes. You aren't reinventing the wheel, you're just pointing the existing swarm at a new hidden doorway.
And the impact of that simple routing trick is staggering. It radically increases the database of available files on the Postman Tracker.
It actually speeds up downloads for the I2P users too, because you are feeding them data pulled from the massive public Clearnet swarm. It solves the very problems that keep people away from decentralized networks in the first place.
BiglyBT is uniquely positioned for this because it works right out of the box. It natively speaks both Clearnet and I2P without needing external translators.
It's very seamless.
And for those who love optimizing their setups, there's a fascinating mechanical adjustment you can make in BiglyBT to drastically increase your speed on the hidden network. It involves adjusting your hops and your quantity down to exactly 1.
This is a crucial concept to understand about how anonymity networks function. In a decentralized maze, a hop is another user's computer your data bounces through to hide your tracks.
Kind of like passing a note in class.
Yes. Perfect example. If you pass it through 5 people before it reaches your friend, it's very hard for the teacher to know who originally wrote it.
But it takes a long time for the note to get there.
And there's a higher chance someone drops the note along the way.
Right.
By reducing the hops and quantity down to 1, you are minimizing the distance and the complexity of the routing. You are only passing the note to one person before it reaches its destination.
Which dramatically increases the speed and reliability of the data transfer.
It does. You are making a conscious trade-off. You are slightly lowering the depth of your anonymity in exchange for vastly improved performance.
For someone running a bridge to supply public files, that trade-off is often well worth it.
Absolutely.
Now, Bigly BT is great because it has all of this built in, but we know most people listening to this are probably already running BitTorrent. It is widely considered the fan favorite.
Oh, by far.
The problem is, forcing BitTorrent to talk to the I2P network is a much heavier lift. It requires some genuine under-the-hood mechanic work.
Yes, and understanding why it's a heavy lift is important. BitTorrent relies on a core engine called libtorrent, and libtorrent was built for maximum efficiency on the public internet, not for anonymity.
It's built for speed.
Right. So it hasn't natively adopted I2P's decentralized map for finding peers, which is a system known as DHT, or distributed hash table, nor has it adopted PEX, which is peer exchange.
That's essentially the protocol where computers gossip with each other about who has what pieces of a file, right?
Exactly. And because it lacks that map and that gossiping protocol, it's essentially blind to the hidden network.
Completely blind. So until the developers rewrite libtorrent, users are forced to manually configure an external bridge to act as a universal translator between BitTorrent and the I2P network.
And setting up that translator involves getting into the configuration files of the I2P software itself, specifically the I2PD.conf file.
Without reading a wall of code to you, you basically had to tell this software how much bandwidth it is allowed to dedicate to the network. The recommendation is to allocate a solid chunk, like a couple of megabytes per second, setting it to P for 2048 kilobytes per second.
And setting your share ratio to 100%, meaning you are giving back everything you consume.
Digital altruism at the configuration level.
Exactly. But the absolute most vital step is turning on something called the SAM bridge. This is the actual translation layer.
On IP 127.0.0.1 port 7656.
You've got it. You enable it so that it runs entirely locally on your own machine. It creates a closed loop on your internal network, ensuring that the translation between the public software and the hidden network doesn't leak out onto the broader internet.
And once that local translator is running, you just point BitTorrent to it.
Yep.
But here is where it gets incredibly practical and maybe a little frustrating for modern internet users. Even after you set up that perfect translation layer, you can't just hit download immediately.
No, you cannot.
There is a waiting period. You have to let the I2P console run for at least 30 minutes before you even attempt to move data. 30 minutes, just sitting there. In the age of gigabit fiber optics, asking someone to wait half an hour before downloading sounds like going back to dial-up.
It really does feel like going back in time, but you have to remember what the software is actually doing in the background. It is not just pinging a centralized server in California and asking for a file.
Right, there is no central server.
It is organically weaving your computer into a constantly shifting, decentralized maze. It takes time for the software to map those blind alleys, test connections with other peers globally, and physically build secure cryptographic tunnels.
You are watching the network status, waiting for a metric called the tunnel creation success rate to climb above 10%. If you try to force data through before those tunnels are built, it just fails.
It really drives home the point that you are plugging into a living, breathing ecosystem, not a corporate server farm.
You are participating in infrastructure.
That's exactly what it is.
Now, if tweaking local translation layers and waiting 30 minutes for tunnels to build sounds like a bit too much friction, there is a third option. A brilliant shortcut using that software we mentioned earlier, I2P snark. Let's call it the quick magnet method.
Right, because earlier we established that people thought I2P snark was only for the tedious process of building torrents from absolute scratch.
Right.
But the community figured out a seamless way to use it to pull public files directly into the hidden network without all the manual routing edits.
It's beautifully efficient. If you don't want to mess with Bigly BT or BitTorrent bridges, you just go onto the normal public internet and copy a standard magnet link for whatever file you want to bridge.
Yeah.
You open I2P snark, paste that public magnet link in, and add it. But before it really gets going, you pause it. You open the file's properties, and you just manually check the boxes for the I2P trackers like Postman and DGTrack.
You save it, and the software handles the rest. It immediately updates the hidden index and starts pulling the public data securely across the divide.
It is a fantastic workaround for the everyday user. It bypasses the need for complex internal routing.
There is a small caveat, of course. This method relies on the file having a healthy amount of public seeders to begin with. If you are trying to bridge an incredibly obscure file with only one or two people hosting it on the Clearnet, this quick method might struggle to negotiate the connection.
Makes sense.
For those rare files, you really do need to download them completely on the normal internet first and then cross-seed them manually. But for 99% of popular datasets or media, it's a frictionless way to populate the hidden network.
So what does this all mean? We've talked about stripping public road signs from routing logic, configuring local SAM bridges, adjusting cryptographic hops to increase speed, and weaving our computers into decentralized mazes.
It's a lot of mechanics.
It is, but taking a step back for you, the listener, whether you are optimizing Bigly BT, whether you're using Locanet as a secure tunnel, or just pasting magnet links into I2P Snark, what you actually hold in your hands is the power to democratize information.
That is the core takeaway.
These tools give you the ability to take data that is freely and easily available in the sunlight and meticulously, securely hand-deliver it to communities operating in the shadows. You aren't just downloading, you become the bridge between divided digital communities.
If we look at the philosophy underpinning all of these technical frameworks, it is the fundamental understanding that knowledge, software, communication tools, none of it is truly valuable unless it is actually accessible to the people who need it most.
Absolutely.
Cross-seeding, network mixing, running translation bridges, these aren't just technical parlor tricks for computer enthusiasts. They are perfect examples of ordinary users quietly, thanklessly maintaining the infrastructure of a free and anonymous internet.
The hidden trackers don't populate themselves.
No, they don't. The network doesn't generate its own speed. It is entirely dependent on everyday people deciding to share their bandwidth, their hardware, and their access with people they will never even meet.
It is the ultimate invisible volunteer work. And it leaves me with a final lingering question for you to ponder long after this deep dive is over. We look around today, and the mainstream public internet is changing rapidly. It is becoming increasingly fragmented.
It really is.
It is walled off by corporate ecosystems, monitored, and in many places around the world, it is heavily censored by different global powers. Technology experts have even coined a term for it, the splinternet.
The splinternet.
So as the borders of the public web continue to close and access to free information becomes more restricted, could these niche, highly technical skills of bridging hidden, decentralized networks shift from being a weekend hobby for privacy enthusiasts into an absolute essential form of digital literacy and survival in the future?
Yeah.
It's definitely something to think about. Thank you for joining us on this deep dive.